Working with the catcher game, we have the basic catcher game. It's got the intersect code in here, but it's not actually checking for the intersect yet in game 0. Game 1, we'll start doing that. But the key thing here is instead of using drops.length as a property for how many times to cycle through the for loop, instead what has happened is I have now set a variable, the number of drops, call it num drops. And this way, if I want to change how many drops are occurring in my project, I can just change this number once up here. Now, designating it in this manner does serve a couple of advantageous purposes. Once we add in the timer to control the falling of the drops, so the drops are now falling not in a massive downpour, but start out 1 and then 2, then 3. It's nice to have this as a number without having to say drops.length, drops.length. Another advantage is down the road we will actually possibly care about performance. Every time I issue the command of drops.length, I'm asking the program to ask the array, that drops array, hey, how many objects do you have? And if I do that every frame, it's not a big deal. But eventually, if I have 2, 3, 4, 10, 100 different arrays of objects in my project, and I'm asking all of those every frame, hey, how many objects do you have? How many objects do you have? How many Eventually, I start to see some performance issues where it gets a little wonky. If I just designate it as a value in the beginning, it no longer has to query. It knows that number, so it doesn't have to think. It can just do. So that's a better option. Whenever you have that as a possibility, you set it up as a variable. So that's why I'm using number of drops right here. So now if I want to change it to 1,000, I can change it to 1,000, test my file, and I'll see 1,000 drops all just fall at once. And yeah, that looks like junk because once they're rolling, it's not so bad. But in the beginning, when they all fall, it just doesn't work really well. So that's what we're going to fix inside game number 1, where it introduces and utilizes the timer object. So inside game 1, when I go over to game 1, it has the timer class with it. So you'll notice that inside game 0, the timer class was still empty. It had no content yet in it. So the timer came from our previous timer file. So looking at that timer file where it had a version 0 and a version 1, version 1 it said, hey, timer. And it would, every time the timer finished, it would change the background color, then it would tell the timer to start again. In this case, it's telling the timer to run for 2,000 milliseconds or 2 seconds. So that's how this timer is constructed. So if I run this timer file just to review it, every 2 seconds it will change to a new random color. It's not very exciting, but it's a proof of concept. It's proving that the timer object works. So looking at the timer is we need a timer variable. We need to know what is the end time we want the timer to stop at. And then we create our timer variable passing in that end time. So when timer is made, it needs to know what is its total time, and that's the time that it gets passed. Then timer grabs the milliseconds from what time the program started running. So the computer has a clock that's running forever. As long as the computer's on, the clock is running. When you start a program in processing, one of the properties of that program is how many milliseconds has this program been running. So we can say, hey, how long have you been running? And it will give an answer back in milliseconds. And then what we're able to do is then compare our starting time versus the current time. So we can say, hey, how much time has elapsed? How much time has passed? And then we can say, what is the current time? And we subtract what time did you start? And that tells me how many milliseconds this program has been running. That's how the timer object is constructed. Now, if you don't want to have to worry about it any further, or in the future, is we just create the timer class, which if you notice, here's the timer class. This is exactly what came out of that timer file version 1. It is the timer class unchanged. right here. So here it is unchanged. So I'm inside game 1, it's timer class. Now, if I go into my game, I will see that here I timer object, end time. So I'm using that timer object, and then I set end time equal to half a second. So I want every 500 milliseconds, or half a second, because 1,000 milliseconds is a second. So every half a second, I want the timer to go off, or to be done. Then I create my new timer, and I tell my timer to start. And then what's going to happen is when the timer is done, I'm going to enable my project to drop a second drop, and we'll look at how that works. But first, to see this run, so it's 1, 2, 3. So every half second they're dropping. If that frequency is too frequent, I can slow it down. If it's not frequent enough, say I want it to be every 1/10 of a second, I want a new drop falling, I can change it. So every 1/10 of a second, just by changing that, now we can see they're falling much faster, but it still is not doing the monsoon. I'm not getting that massive monsoon effect. Even if I say I want 10,000 drops, whether I have 100, 1,000, or 10,000 doesn't matter. It's just going to only pull out one every 1/10 of a second. And then I just have to wait and wait and wait, and they just keep falling. And eventually, if I don't catch them, they keep cycling through. So the number of drops is not really that big a deal now that they're not all falling at once. Our timer, we can set it so 1 per second. We want it to be really slow and pokey. 1, 2. So they come in 1 per second. It's kind of slow. Now it doesn't, if you notice, that felt like a different amount. It didn't feel like 1 per second because once they went off screen, they went back to the top and dropped in again. So sometimes it appeared 2 or 3 were falling at once, but it still is preventing that monsoon drop of everything falling at one time. So we're using the timer class. We're creating a timer object. But in addition to our timer object, what we need to do is figure out how many drops we want to currently have active. Active meaning those drops can be animated on screen. And that's the real change that we're going to be looking at. With the active drops, it's just a number, and I'm going to start it out at 0. So active drops is how many drops are currently falling. So when my program starts out, I want it to be 0. After the first tick of the clock, I want 1 drop to fall. Then I want 2 to be able to be animated. Then 3 to be able to be animated, and so on and so forth. And the way that it occurs is this little chunk of code here where I say, hey, if the timer is finished, then I have to do one little thing where I have to say, hey, if active drops is less than my total number of drops, then I want active drops to increase by 1. And then I tell my timer to restart itself. So the way that this works is active drop starts at 0. So the first frame through, nothing happens. The second, nothing, nothing, nothing. When I hit half a second, my timer's finished. Timer finished will send me back a message. I'll ask, hey, are you done yet? And I'll be like, thumbs up. I'll say, sweet. And then I compare and say, hey, is active drops less than my total number of drops? And if the answer is yes, it will run. Otherwise, what would happen is I could run this, and then once active drops got up to 101, I would get a out of bound index array error message that it'd be all grumpy with me and scold me and tell me that I'm trying to ask for something that doesn't exist because I'm trying to get to an object beyond the limits of what my array currently has. And I'd be like, oh, I don't like you, go home, go cry, you suck, and it just makes you feel bad. So we don't want to do that. So we put it in this little if statement just to prevent that from happening. Because at the end of the day, we want active drops to max out at number of drops. Because if this is at 99, active drops is 99. 99 would be less than number of drops, that's 100. So then active drops would become 100. And then my timer starts. Then the next time through it goes, hey, the timer's done. And then it will say, oh, active drops, you're at 100. That's no longer less than number of drops, so we're not going to make active drops any bigger. We won't go any bigger. And then that's all there is to that with that. So to see this in action or see it a little bit more, I mean, if we were to comment that out, lower our number of drops down to a smaller number, we would see it would air out very quickly. So I'm going to just make this 10 and hide these a little bit, and then we can see a little bit of what's going on. So if I run this again, and now it failed because it's running out of array index out of bounds exception, so it got really unhappy with me. So, didn't want to. That dropped them all at once. Let's try again. We'll still get the same error message, but it will be now one at a time. 1, 2, 3, 4, 5, 7, 8, 9. Boom. So once 10 drops were actually on screen, failed out. Array index out of bounds exception, so it tried to make active drops became 11, and it then failed out. So the way that we're using it is I commented out line 37 here, which has number of drops in it, which is in game 0, when we're animating, we say, hey, for I equals 0, I is less than number of drops, I plus plus, and then we tell all the drops. So in game 0, where we get the monsoon, all the drops are told to animate themselves. Every drop, all 1,000 drops are told to update and display themselves every frame, because we go through our entire array of objects. In game 1, we're only going through the number of, we're setting, instead of number of drops, we're using active drops. How many are currently active? It starts out at 0, then it becomes 1. So we can see I left the commented one here out, the original one where it said number of drops, and I just changed it to active drops. So this is a line that changed. Add in the timer, change that. So now I tell those drops to update. So the first time through, it's 0, then it's 1, then it's 2, then it's 3, and it just keeps on going until active drops is equal to number of drops, and then it performs the same where they're all falling. And then this one also has the intersect in, which we did have last class that I forgot. I should have put that into game 0 since we did have intersect working, and it's still working now, where we just are comparing. We ask, hey, has intersect of catcher and drops, is that true? If so, I modified the drop class a little bit and added in a caught function, because I knew that I wanted it to be caught. I wanted to change something on it a little bit, because by using caught, we're able to have more flexibility of what we want to have happen within the drop. So I'll take a look at that next. So looking at the drops, we're going to talk about the caught function that is built into it, because previously if we were doing something along the lines of drops I dot y equals, and we could just say y equals 0, drops I dot speed y equals 0. So I mean, you can manually set the object's properties right here. But it's a better programming practice to just call methods, because ideally my main project shouldn't really know or care about the properties of that object. What it should do is just say, hey, you've been caught, and let that object worry about, well, if I'm caught, what am I supposed to do? And we let the object worry about what it's supposed to do instead of the main program telling the object what to do. So once we start using classes, it's better to separate that structure out so that anytime we're dealing with our objects, we tell the object, hey, just do this and let the object can figure out how to update itself, how to display itself, how to be caught. It knows that. And it's a better process to do that. So I'm going to get rid of those there. We tell the drop to be caught. Now if I go into the drop, we can look and see what caught is, where caught is just simply at the moment we're telling it to set its y equal to 0 and its speed y equal to 0. In a subsequent file, you'll notice there's a subtlety where we actually are able to tell a drop to reset itself. So we can tell the drop to reset itself. So it sets its x to a new location, it sets its y to what it needs to be, it sets its speed to a new value. So the drop is now ready to be reused again. Because at that point we can start to build reusability into it so that if we want to be able to play again, so after we win or lose or draw, we can play again, we can tell the drop, hey, reset yourself, so it's all ready to go. So the drop has been caught. One other change I'm remembering from last class is I did integrate, instead of having my background 255 statement at the beginning of my draw loop, I made a function called clear background because I wanted the possibility of perhaps it's not just simply flood the background with white. Maybe my clearing background is I draw a rectangle, I draw a few more rectangles and circles and triangles and I make a whole picture in a scene, and that's clearing the background. Well, it's easier to have it now self-contained in its own function than to have my draw function get to be so many lines long that I can't find anything. So anytime you have a little bit of code that's kind of doing something, it's a good practice to actually just to put it into a function. And we'll start doing more and more and more of that as our project develops here. Inside game 2, it's adding in a scoring mechanism. So it's added in 2 new variables. It's added in a score variable, and it's added in a string variable. The score is an integer. S is now a string. It's convenient when we have to put together words and variables and numbers and other things to have a variable to store that in that is just a string when we're trying to fit it in. It's not absolutely required, but I think it makes for a little cleaner code and it's a little easier to work with. So I would encourage you to take that approach. So score starts out, of course, at 0 because this is an affirmative game. The more you catch, the higher your score. And string starts out, you'll notice, with empty quotation marks, as in an empty string. I could get away with not even giving it a value because I do assign a value before I attempt to show it on screen, but it's always a good practice to give all of your variables an initial value, even if you will then assign, kind of the real value later. So even if you give it values of 0 or empty strings or something, you still give them a value. That's a good practice to get into. Now, when a drop has been caught, my score variable goes up by 1, score plus plus. So I just get 1 per. If I wanted to get 2, it'd be plus equals 2. If I wanted it to go up by 5, plus equals 5. So whatever I want my score to increment by or decrement by, I would use the appropriate way of representing that. I chose a fill color of red for showing my score on screen. I will use the string S and I will give it a value of score, and then I put a plus, and then I put the actual variable score here. So it will now display it on screen. So initially it starts out at 0. And then I am using the text command or the text method, and you specify what text you want to show up on screen and the X and Y coordinates that you want it to show up on screen. That's what the 10 and 20 represent. 10X, 20Y. So when this runs, we will see red text in the top left corner that specifies what my current score is. You will notice that it sits on top of my catcher object as well as on top of any of the drops that fall behind it because it comes last inside my draw loop here. So inside my draw function, the very last thing is I say, show me the score. So it draws that on top of everything. So that was intentionally placed there versus putting it, if these lines were at the beginning, right after a clear background, then you would notice that my catcher object can sit on top of the score. So order does matter. It's important to keep track of that. Looking at number 3, number 3 introduces the concept of a game state. So with this, it has an initial game state of start, and it's waiting for me to click on the red button and to tell that button to play. So once I do that, it's going to change my game state from start. When I click on it, it will change my game state to play. And if my game state is play, then it makes the cursor goes away, and then it has all the information about playing my game. So now we can see it's playing. There's a few extra things here that with the text that weren't present in the previous that I will go into as well, but otherwise the core game is still the same. So what we have going on with the game state is game state is representative of a state our program is in. So in the world of programming, this sometimes gets referred to as we've created a state machine or a state-based machine, and we're trying to keep track of what state are we in. We start out with a start state, and then we have a play state, then we could have a win state, a lose state. We could have a level up state, so that instead of win and lose, win is more along the lines of you passed a level, and now you can click to continue, and that now levels me up, and now I have additional challenges in my gameplay. And then we can level up and level up. So maybe every 10 drops I catch, the game gets harder. They fall faster. There's more of them. There's a higher cost for missing. You get to determine that kind of structure and logic. Now, to that, you're going to have to do some trial and error, some experiments, put in code, find out what works and what doesn't. But game state itself is utilizing a simulated version of what's called a constant. Within programming, we have the ability in certain languages to construct something that's referred to as a constant. This constant would be a variable that has fixed values to it, and once the program runs, we can't update or change what those values are. So if we have 6 states to our game, we can't add a 7th state while the game is running. We can't add an 8th state. We have 6. We started with 6. We will always have 6, and that's how many it has as long as that version of the game is running. What we're using is not quite as strict, but what we're going to do is use a string variable, and we'll call it game state to represent this game state. We assign its value, and because it's simulating or representing what would be a constant, we put it in all capital letters. An advantage of doing that is when you look at the code, it is easy to find that all capital letter word. Our eyes are able to scan the code and see it easier. That's one of the bonuses of using a constant when we're programming. So now my draw function, you will notice, is broken into an if statement. It says, hey, if game state is start, do this stuff. Else, if game state is play, do this other stuff. Now, if we had an additional game state, we could have something like else if game state is equal to win, do something, do my win stuff. Else if game state is equal to lose, do my loser stuff. So we can extend our different game states to be all the different versions or things that we want, and then we start putting into it what we want to have those states do. So my start state sets my string s equal to click to play, and I'm using the /return or backslash or whatever slash that is with the n. That slash with the n tells this text to break onto 2 lines. That inserts a carriage return. It inserts a line break. That's what that /n does. So with that /n, then I say text align center to center the text, set the size of my text, set the color of my text, and then I put the text on screen. Change my color to red, and I draw a circle to be the big red button. So that then gives me this result. So we can see the blue text, the red circle. So again, when game state is start, I set s equal to click to play, center my text, bump it up to 18, fill it with blue, draw the text, change the fill to red, draw a circle. Because I'm drawing a circle at the center location on screen, I am then going to use a statement that allows me to calculate the distance and figure out, hey, the distance between my mouse and those numbers there, you will realize, come directly from this ellipse, which would be the center of that circle. So the center of the circle and where the mouse is. So I'm comparing where those 2 points, and if the distance between those 2 points, the mouse and the center of the circle, is less than 30, knowing that my ellipse statement drew a circle 60 wide, not 60 radius, but 60 diameter, so its radius is 30. So from that center point, if I go over 31, I'm not on the red circle. As soon as I'm at 30 or less from the center of that circle, so it's the same kind of circle collision detection we're using with our intersect function. If the distance is less than the sum of the radii, well, the radii are 30 and 0, so less than 30. That means those 2 objects are intersecting, or those 2 points. I decided it looked better if the cursor changed to a hand when you roll over it. I think that looks better. Tells you it's clickable.
Is that hardwired into processor?
Cursor hand, cursor arrow. So we're able to do it. So center the text, update the size of the text. Now I'm going to change 2 things real quick here and run this again. And what we'll notice is, okay, the text is blue, it's centered. I click here, and now if you notice my text is still big. Oh wait, it went to red, that's great, but it's still centered. Crap. So when I was making this, I went, oh yeah, because here I said text center, text align center, text size 18. Until I say otherwise, it's going to stay on that setting. So that's why anytime you change the fill color, change the text size, change the text alignment, the next time you're putting text on screen, it's a good practice to just go through and specify size, alignment, and color. That way, when you put your text on screen, when you get to the next thing, it will be correct again, and now we can see it is indeed the correct color and size. So check to see if my mouse is intersecting the circle. If it is, I make the hand show up. If I press the mouse, I change the game state. But if the mouse is not intersecting the circle, I want the cursor to be the arrow. So it goes back to the hand. Because otherwise, if we don't have that little statement in there, and this, I didn't have that else in there when I first did it, so it kind of looked like what you'll see in a moment. Okay, arrow, 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 point. Oh, shoot, it's still the hand. doesn't go back. Because once I turned it, I never came up with a way to undo that. So that's why we need to have, if this is true, change the cursor. Otherwise, change it back to that, to the default state, which is the arrow. Mousepressed is an event we can listen for. We know that this mouse press can only occur when we're inside that circle. Because if I'm not inside the circle, I don't get to these lines of code. Therefore, I can press the mouse until my finger falls off and my mouse breaks, and the game will not switch its game state. But if I'm inside the circle, I get the hand cursor. Then if I press the mouse, it changes my game state to play. Once my game state has been changed to play, it's going to stop doing any of this code, and it's now going to start running this code, of which line 55 introduces a new thing related to cursors as well, which is no cursor. No cursor says, hey, I don't want that cursor on screen. So you may not have noticed that was happening, but I'll turn the cursor back on so we can see what happens when the cursor is and is not there. Arrow, hand. Okay, now we got, oh shoot, now I still got the hand pulling around the circle. Well, it's kind of comical, but it's not what I want. Because when we see that hand, we assume that that's a clickable object. That's the user interface assumption that we make, because when it becomes the hand, it's clickable. So we don't want that. So in this case, I could have said cursor back to arrow, or wait, or whatever, obnoxiousness I want. Or I can say no cursor. So now I just see the artwork. So it seems like as I move my mouse, it's updating and moving that artwork. And if my artwork is more than just a circle, but is indeed some type of more interesting created object, then it seems like as I move the mouse, I'm moving this real thing around on screen, and it's a cool experience. It creates that game type experience. Whoa, you let it run for a while and it just pours. Adding in the language for winning, we need to ask the question, if my score has reached the amount I want to be able to win. If so, I just update my game state to win. That means as I finish this frame the next time through, this is now true because my game state is no longer play. It's certainly no longer start. So that means my game state is now win. And then I update what I want S to be. So I say S, hey, now you're set to positive affirming message. I copied the code for displaying it on screen using the same code that was inside my start section here, where I grab my align, my size, and fill and display. So just copied those lines, re-put them here. Boom, that now puts it on screen, and it gives me a win state. The drop in game 3 changed a little bit. It got a reset function. So in the reset function, it's now able to set its X, position itself up top screen but off screen, and then it gives itself a random speed. Realizing that same code was right here, we're able to then put that into a function. An advantage of having reset in a function, so I just call my reset function, it calls reset, is now I can use that more frequently. So when a drop goes off screen, we could tell a drop to reset itself versus, say, finding out that that drop did go off screen, and we need to do it because if a drop is caught, its speed gets killed and it is being put off screen. Previously on like version 1, they were just put at the top of the screen, but they're off screen now, so it looks like they disappear. But when we want to be able to replay the game, so I can say, hey, try again. To be able to try again means we need to reset these drops to tell the drop, hey, drop, I want you to be able to fall again. That means it needs to get a speed y that's not 0. When speed y is 0, the drop just sits in place. We keep telling it to update itself, and it updates itself by adding in its speed y. Well, if If I add in 0, not a lot's going to happen. So eventually we will want to call reset when we click on a try again button. But what we probably are going to need to think about is adding in a function that was in the very first version of the catcher project we were working with, where we had a check bottom function. I got rid of it earlier on in this version, and now I realize we probably will want to bring that back. So in one of the very first catcher projects that we were working with, we had a check bottom function. So I'm going to add that in here, and then we're going to work to figure out how to integrate that in a little bit better. So adding in that check function, just put it higher on screen here. Check function is going to be a Boolean, and then it will be a function, and my autocomplete's not really helping me here. So check bottom is just going to find out, have we hit the bottom of the screen? So we had check bottom, where then our update called check bottom. Now what we're going to do is call check bottom with that information. Whoop, missed a line there. With this information that we have up here. So we ask, hey, is the y greater than the height and even a little bit more, and it's off screen? If so, we can set it equal to that. But what's even more important, and this means then the drop isn't going to necessarily disappear, but what we need to also do at this point is say return true. So this function, like a void function, doesn't return anything. It doesn't give you anything back when you work with it. A void function just simply, it runs, it executes, and that's it. When we have a function that has anything other than void as its return type, such as Boolean or int or float or string or something else, it needs to return something. So we say, hey, if I have gone off screen, we're going to return true, else false. So it returns either true or false, but before it returns true, it also is going to set its y so it's back up on the top of the screen there. For that matter, instead of just doing that, this could even be a nice, so that it doesn't keep kind of, if I miss it, it keeps falling in the same place with the same speed. So if it truly wants to feel like it's a new drop falling at the same one I missed, we can tell it to reset. So it moves to a new x, goes back up top, and now it's going to fall this time with a new speed. So this can be a way that we can create the illusion that we have more objects in our game than are actually there. So we don't need to create 10,000 falling objects to make something that keeps running and appears to be random. So it's the same drop. Every time it goes off screen, it's going to fall at a different speed from a different location, making it a little bit harder to catch if we miss it. Now we have a return true, and we have a return false. Now that the drop is capable of checking its own bottom, we just need to, in our game, we can figure out how we want to integrate that. So here we can say, as an update a drop, display the drops. We check to see if the drops are intersecting with the catcher, thus improving our score. And for now, what we can do is we can now take away from our score here, and we'll do that as an option. You could think about, if you miss, it's taking away your lives, or you can rename things. If you put a new name on something, it suddenly becomes a whole different ball of wax. Just like my tank game suddenly became Fluffy Unicorns by just changing the artwork and the speed of things, but it's the same game. All I did was change the artwork and modify the speed so it looks like it's going slower, because unicorns shouldn't fire missiles at high speeds. It just didn't make sense. And then change the missile to a heart. But changing the artwork, changing the terminology, it becomes a whole different beast at that point. So now we can say if, we're going to ask if that particular drop, check bottom, So we're asking, does that function return true? So if it does, we want something to happen. So at this point, what I could say is score minus minus, so it takes away from my score. And then if score is less than 0, meaning it's now a negative value, because the score starts at 0. So I can't say if my score is 0, I lose. But if my score drops below 0, then we're going to say we're a loser. And say game state is equal to lose. So that now kills it. And now all that's left is to populate what happens inside my loser stuff. So if I lose the game now, what will happen is I will go to here, and it will now just be a white screen. So if the screen goes white, we know we lost. So to run this again, I click. Now if we just let even the, oh, cut that one. Now let's let a few drop down. Oh, failed. The trick is figuring out how to restart on this, but now to go over the issue again of why it wasn't working, inside the drop under its update previously was telling itself right here, it said, hey, if I go off screen, go back up to the top, go to negative r times 4, so approximately minus 32. Then when I would call check bottom, it says, hey, if you're off screen, but the problem is the drop would update itself. So, oh wait, I went off screen. I'll go back to the top. Now I'll display myself. Then I see if I've been caught. Sweet, I haven't been caught. Check the bottom. Well, I can never hit a bottom if I've already been back to the top. So remembering that the code will execute in the order that it's listed means it's very important under inside the drop under update that it's no longer doing that.